Hello, my name is Ivan Taylor, and I'm from Ontario, Canada. And I'd like to share with you today some work that might be interesting to people in Latin America. I'm a member of the one-on-one mentorship program of the System Dynamics Society. And that's given me an opportunity to meet people all over the world and help them learn the basics of system dynamics. And I want to talk to you today about some projects that my mentees are working on that I feel you might be interested in. And then I'll have some concluding thoughts. So the first project I want to talk about is a Bangladesh fellow who's studying dairy farming. The second project is a Bangladeshi fellow who's studying pollution in a major river. The third person is a group of people in Colombia that are studying COVID and trust in government. The fourth project is from a person in Iran who's studying COVID vaccination programs there. The fifth project is from a fellow in Nigeria on energy security. The sixth project is with a fellow from Pakistan on economic growth. The seventh project is with a fellow from United Kingdom on the refugee crisis. And finally, I want to talk about a project that a fellow in the United States is doing on the United Nations Sustainable Development Goals. So let's start with the dairy farming project. The idea of this project is to demonstrate a way for dairy farmers to increase their income and reduce their waste by turning waste into biogas. And the audience of this project is farmers of large to medium-sized dairy farms and energy regulators. So this is the model that my mentee developed, and there's 5 sectors. There's the production sector, the milk production sector, there's the dairy waste sector, there's biofertilizer, raw dung, and biogas. And these are all interconnected sectors, as you can see. He collected some data from the dairy farm on the number of cows and calves and the amount of waste that they've produced. And we were able to calibrate the model to match the data and then estimate the parameters for looking at what if scenarios. Here is the results in one page of the baseline case for the dairy farm over a 36-month period. And here are the results of the phased in process of building a biogas plant and using it effectively in the dairy farm. And on the left is the income that is increasing as the phases are, as the dairy biogas program is phased in. And on the right is the amount of landfill that is produced as the phases progress. And that paper was developed into a journal article that is currently under review. The second project I want to talk about is a Bangladesh fellow who was studying pollution in a major river. And his goal was to show the return on investment from waste treatment plants in terms of inclusive wealth. And his audience was regional and city planners in Bangladesh. So he's got a model that involves inclusive wealth that is based on human capital, productive capital, and natural capital. And all of these things are affected by the pollution in the river. And if the pollution can be reduced through waste control and through increasing the river flow, then all of these things will increase the wealth of the community around the river. So here's the model of the pollution in the major river. So BOD stands for the biological oxygen demand, which is the pollution, and DO stands for dissolved oxygen, which is the measure of the water quality. And you can see that these measures are highly interconnected. We have a natural capital sector for the model, which involves all these aspects of the natural world around the river and the benefits that the nature provides the community in terms of, for example, fishing and parkland and protection against flooding. There's also a productive capital section in the model, which is involved with infrastructure and working people and the traffic that could be reduced through a proper pollution control. And then there's the human capital sector, which is primarily focusing on the health and well-being of the people in the community. He looked at 3 scenarios. 2 of the scenarios simply involved increasing the water flow of the river. And you can see that in terms of inclusive wealth per capita, these measures were not as effective as people might think in improving inclusive wealth. However, when he added some effort at introducing waste treatment plants to treat the water before it went into the river, then this was had a good result in the long term. It had a sort of a effect of worse before better, but looking in the long term, there was a considerable improvement in the inclusive wealth per capita from this idea of introducing waste treatment plants. The next study is some work that we did on trust in government and how COVID-19 in misinformation or control of information might have affected the trust in government. So we want to show that information management affects compliance of citizens with public health initiatives. And the intended audience is public health officials. So we had a simple model of COVID-19 in terms of susceptible, infected, and recovered. And we had this other model connected to it where we have this idea of precautions that are introduced by the public health organization and the government. And these might involve regulations. And then the regulations are placed on for particular amount of time, and then eventually they're removed or lifted, and the people can conduct voluntary precautions. So the question was, how well will the people in the public respond to these public health initiatives? We had a trust in government model that showed the impact or the effect of information on on the people dying of COVID, infected of COVID, and recovering of COVID. And that became a proxy for trust in government, which influenced the trust in government. And this shows the impact of trust in government on the number of people infected. We projected on the number of people infected and the possible deaths from COVID-19. And we can see that based on different levels of trust, we can see that there's significant differences in the number of people infected and the number of people dying from COVID-19 in our scenarios. These two graphs show how the importance of the information on people infected and the trust in government. And again, we have the importance of good information on reducing the number of deaths in the citizens. The next project I want to discuss is a project on a vaccination program in Iran. And this study was intended to speed up and increase the effectiveness of the vaccination process for COVID-19. And the intended audience was public health officials. Again, we have an SIR model over here on the left, and then we have an extended model over here on the right of the vaccination process, which leads eventually to a population that is immune to COVID-19. The interesting idea here is that we have people who are recovered from COVID getting vaccinated and people who are susceptible but haven't had COVID getting vaccinated. And the idea here is that the people who are recovered may already have antibodies in their system, and they could be tested before they're vaccinated to determine whether they would only need one dose or whether they would need two doses or one dose or two doses of the vaccine before they would be considered immune. And so by testing these people and considering their antibody levels, we may reduce the number of vaccines required and that thereby save money and also speed up the process of getting to herd immunity in the population. Here's some data that was collected on the vaccinations in first dose vaccinations on the left and second doses on the right. And here is the estimates in the model shown in pink and the data in blue for cases on the left and deaths on the right. The next project that I want to describe is on energy security. And the problem here was to show how renewable energy can support an unreliable electrical grid. So the audience here were facility operations managers. And this model considered not just energy security, but also economic growth that leads to energy demand, and energy security, which leads to economic growth, and also environmental protection, which is important because the energy security currently is being provided by standalone diesel generators to supplement the electricity produced by the electrical grid of the nation. So there was 4 sectors in the model. There was airport operations, energy usage and security, environmental impact and regulations, and economic growth. And these 4 sectors are interconnected. And then this is some data that was collected on the amount of consumption of electricity that was produced by the grid in red and the diesel generators in black, and the total consumption in blue. And you can see that about 50-50 division between the amount of electricity supplied by the grid and the amount of electricity supplied by standalone diesel generators, which of course would produce a lot of emissions, a lot of carbon dioxide emissions, and therefore moving to renewable energy would improve the environment and also improve the energy security. The next model I want to talk about is a model that a Pakistani fellow who was working on to show how improving institutional quality can support national economic growth programs. And his audience was senior economic advisors to federal governments in the developing world. And he works in the Planning and Development Agency of the Punjab in Pakistan. He developed a model that included 16 institutions that are both governance institutions here on the left and economic institutions on the right. And all of these institutions affect economic growth, as shown here in the middle of the diagram. Some of these institutions affect it directly, and other institutions affect the economic growth indirectly. In terms of the model, the causal, the stock and flow diagram, we modeled it with a stock for economic growth and an idea of progress in economic growth that could mean improving economic growth or increasing economic growth or declining economic growth. And then there is government programs to improve economic growth, but these are affected by institutions in the country that may either enhance or limit the ability to achieve the goals of the government programs, and these lead to changes in economic growth and the changes over time. So here's this model was interesting to me because it could be applied to any country in the world, and we set it up so that you can run the model by inputting the name of a country, and it will generate the model for that country. So here is an example of how the model being applied to Mexico. And you can see the projection of economic growth into the future for Mexico, and the data is shown in blue. I'm working with a fellow in the United Kingdom on the refugee crisis, and the goal of this project is to show how reducing violence and ending civil wars might resolve the refugee crisis. And our intended audience is the United Nations High Commission for Refugees, international diplomatic corps, and non-governmental organizations. So we built this model of the flow of refugees from a crisis country to refugees in neighboring countries and becoming possibly immigrants in third countries eventually. There's also deaths in violence and deaths in protests that could occur. This civil war or violence spurs on the departures from the crisis country to the third neighboring countries where they become refugees. So So we collected data. This was this model was applied to the Syrian civil war, and we collected data on the combat and the battles that were being fought in Syria over a 10-year period, and we calibrated the model to match the data. And then we also had data on the refugees that had left Syria, and we calibrated the model to the data on the refugees. And then we projected into the future based on an idea that a certain number of refugees will become immigrants in third countries. However, we believe that it may be the case that these third countries will reach compassion fatigue and will stop accepting new immigrants in the future. And that will create a crisis in the refugee camps, where the population of the refugee camps in the neighboring countries will continue to grow for many years. And then our model, our solution to this was to stop the violence and end the civil wars in the countries of crisis countries, and then try to repatriate the refugees back to their country of origin. And this shows the possibility of repatriation at various levels of violence in the country. The last project I want to talk about is a project that a colleague of mine is working on on the UN Sustainable Development Goals. And the goal here is to demonstrate the interconnectedness of the UN Sustainable Development Goals. And the audience for this, the intended audience, is the United Nations Division for Sustainable Development Goals and National Planning and Development Agencies. So this table of correlation coefficients was developed by the Sustainable Development Goals Reporting Organization. And we use this to develop our causal loop diagram. And then we use the causal loop diagram to produce this picture of a stock and flow. So this is just for one goal. We have this goal as a stock that changes over time. And then we have the target that is intended to be reached. However, that again is modified by the other goals that can enhance or inhibit the ability to reach that target. So this is an example of the results that we got. We had some data, just not that much, but about 4 years worth of data on the current state of each of the 17 UN sustainable goals for almost every country in the world. And so again, we set up a model that you input the name of the country, it extracts the data for that country, and then tries to calibrate the model for that data, and then extrapolates into the future using the cause and effect relationships that we were modeling between the Sustainable Development Goals. So that's just a few of the projects that I'm working on with my mentees that I thought might be of particular interest to the Latin American audience. And just as concluding thoughts, I just want to mention that you can probably see that I find this mentoring program to be very rewarding. And I think that it's also very helpful to the mentees who are learning how to apply the best practices in system dynamics. With modern technology, like for example, Zoom and WhatsApp and Skype, I'm able to mentor people all over the world on a weekly basis at almost zero cost, which is a really amazing opportunity. And I've met many eager young people interested in applying system dynamics to problems in their countries. And that has made me very optimistic about the future of system dynamics and the future of the world. So thank you very much for your attention. And if you have any questions, you can reach me at this email address.